All right, so we're going to go over Unit 1 test review. So if it's helpful on number 1 and really all these first set of problems, graph the reference points for the parent. I'm not going to connect the dots here. But now I know we've got a negative out front. That's going to reflect it across the x-axis. I'll write it down here where it says describe the transformation. And a +5, remember that +5 is on the outside. A lot of people struggle with this because there's technically no parentheses, but you kind of have to imagine a parenthesis around the x there. So we are going to reflect across the x-axis, and then we're going to go up 5. So that's what this one should look like after you reflect. See, I've got it in blue, and then I'm going to shift all of those points up 5 units. So my final answer, really the only one that should be graphed, is there in black. So number 2, do the same thing, graph your reference points. Really can only fit 3 in there. Describe the transformation. The 3. We're going to stretch the y's by 3. And then the -1 on the inside is going to take us right 1. So remember, a stretch 3 is you're multiplying the y value by 3. That's not a vertical shift of 3. So you'll notice that's reflected there with those blue points. And I'm going to shift each one of those blue points right 1 to get my final answer. So you're multiplying whatever the y coordinate originally was by a factor of 3. Number 3 is pretty straightforward. +3 on the outside. We're going to go up 3. I'm just going to use arrows. -1 on the inside is going to take us right 1. So again, there's my reference points, and then I'm just going to do this shift all at once. Take each one of those reference points, shift them up 3, right 1. Really the key there is the vertex. All right, number 4, you got to be careful on this one. This one's a tricky one. And it's tricky because there is a Lie coefficient on the inside of that absolute value. So first thing you want to do is you want to factor out that 2. Think about 2 times what will give you 1. Well, 2 times 1/2. So we've just divided a 2 from 2x and from +1. So now really this is the function we want to describe the transformation for. That one we know how to do. So the 2 outside is going to stretch the y's by 2. And then the 1/2 is going to shift us, that's a positive, so it's going to shift us left 1/2 unit. That one, got to be careful there. And the +2 on the outside is going to shift us up 2. So I'm going to start by doing the stretch. For the stretch, you are multiplying, or in this case, we're just doubling the y coordinate. So that y coordinate is 4 above. Next y coordinate is 2 above. It's just double the one that's right underneath it. 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. So that's after we stretch it, and now we're going to shift each one of those green points left a 1/2 unit and up 2. So these points aren't going to be perfectly on the grid lines. Do your best to get them where they need to be. You may need to erase some of the previous drawings to see it. You can see why we don't do too many shifts that require a shift of a decimal, like 1/2. But your answer should be really close to what I've got there. So there's the parent function points. And then let's describe the reflection, the negative out front. That's a reflect across the x-axis. Again, I always like to do the reflection first. You don't have to, but it'll make the reflection actually be across the x-axis. And the +4 on the inside is a left 4. So there's the reflection. And then there is the points shifted left 4. Sketch your graph. There's your answer. Remember, it does not have left in behavior. It's kind of a broken graph. That's what it should look like. And then finally, this last one, just a left 1 shift. So there's the parent function point. Just shift those points left 1, and that's it. So there's your answer. Remember, make sure your points can actually show up. So notice one of these points, after I go after the function, it's kind of hard to see. So go back. You've got to have the points. Can't just draw the shape of the graph about where it should be. You actually have to have 3 to 5 points for these. All right, here's slightly different notation, but the same idea. We're going to graph each transformation. So use the same rules. The 1/2 out front. It doesn't ask for this, for you to describe it, but I'll go and do it. We're stretching the y's by 1/2. Or really, it's more of a compress by 1/2, I guess I should say. And then we're shifting all those points down 1 after that. So the compression, you're just taking, basically, it's half the distance to the y-axis. This point up here is, what, 5 above. So its compression should be about 2.5 above. So that's what the compression should look like. Of course, the points that are on the x-axis, the compression does not affect those. And then you're going to take each one of those blue points and shift down 1 unit. Be careful on the ones that are 2.5 above. When you shift them down 1, they should still be halfway in between 2 of those grid line intersection points. Make sure you have 7 points, because that's what we started with. And then graph your function. Second part of 7, I guess. This is a reflection. Negative out front. +3 on the inside. It's going to shift us left 3. -1 on the inside is down 1. So I'll start with the reflection. This point here is, I guess it's the same graph. So this point here is 5 below. So its reflection should be 5 above. The reflection does not affect the points that are already on the x-axis. And then we're going to take each one of those green points, shift them left 3, down 1, all at once. So there's the points. Just make sure you've got 7 of them. Again, the shape of the function should not change, just where it's been has changed. I guess the shape's been changed a little bit because it's been reflected, but you still have the 2 humps just like the original. And the last section, you're just matching up the functions. There's just a little bit of vocab. This one is obviously linear. It's a straight line. That's the square root. U-shape, that's a quadratic. And then this one, absolute value. Make sure you know those vocab words. So here we're going to write an equation to represent each of the following graphs. So this first one is an absolute value graph. So I know that I'm going to have an absolute value symbol. We'll leave some space on the inside, although it looks like in this case we are not shifting left to right because the number on the inside is the left and right shift. So notice this one still lines up with the origin, so it's not left and right shift, but we have shifted down to that vertex. And it looks like that V-shaped graph is a little bit skinnier. It's been stretched out a little bit, and you can see here pretty quickly that instead of going up one, right one, and up one, left one like we normally do, in this case they have gone up two, right one, and up two, left one. So the y coordinates have been stretched out by a factor of 2. I don't have enough space to fit it in that little blank, but that's where it should go. And then number 9, this is a radical or square root function. Leave a little bit of space. On the inside and out front, we notice this one has been shifted. It's normally at 0, 0, but it's been shifted from that point. It looks like left 4. So a horizontal shift of 4 goes on the inside. And it's got to be a plus 4 on the inside. Plus 4 on the inside shifts us left 4. There's been no vertical shift. Looks like there's been no stretch because the preceding point is just up 1, right 1, just like the parent function. So that's all you have to do on number 9. Number 10, state the zeros, the x-intercepts, and the y-intercepts for the following functions, or state none, where zeros and x-intercepts are the same thing. So this one does have x-intercepts. Looks like it crosses at -1 and -3. So usually zeros, we just write them as numbers with a comma in between them. X-intercepts, those are ordered pairs. So I'm going to write those as ordered pairs. Does this one cross the y-intercept? It's kind of hard to tell where it crosses exactly. I don't have anything that's this tough to tell just visually on the test, but I believe the y-intercept is at 0, -3. This next one, they don't give you a graph. You don't have to graph it. It's not part of the problem. It's probably going to be handy. You could use the graphing calculator since this is on the graphing calculator section. But I'm going to graph this one as a down 1 shift and left 2. Really, that's enough of the points to graph. We don't really need to see the left-hand side. We just need to see where it crosses. And it crosses at -1, -3. I guess that's the exact same place as the last one. A little too big there, but those are my x-intercepts. And the y-intercept is at, crosses the y-axis at 0, 3.